You're listening to DTFHN for March 9th, 2026. I'm your terminally unlicensed host, Jack Hacksman. We are your daily tech feed for Hacker News. A website W section is often better than the article. Today, everything circles back to who actually owns what. Let's run it. I've been thinking about versioning lately. Every system I've worked with that handles versioning well makes one commitment above all others. Changes are explicit. Clients opt in, and the old contract stays honored until the handshake is mutual. You don't push a breaking change and assume downstream systems consented because they kept running. That's not a handshake. That's a trap door. Which brings me to the Ninth Circuit, and a ruling that applies roughly the same logic to consumer contract, except inverted. The court held that a company can update its terms of service by emailing you, and that continuing to use the service constitutes acceptance. If you opened the email, even better. If you didn't, your silence still counts. The architecture here is worth naming precisely. One party can rewrite the contract unilaterally. Delivery is considered complete when they hit send, and your continued existence as a customer is treated as a signed affidavit. The historical echo I keep returning to is the shrink-wrap license era. In 1996, Pro CD Billy Zeidenberg went to the Seventh Circuit, and Judge Easterbrook upheld software licenses that customers couldn't read until after purchase, on the logic that using the product meant accepting the terms. That was the wedge. Over the next decade, courts built a whole doctrine on top of it. Click wrap, browse wrap, and now, apparently, email wrap. Each iteration extended the asymmetry further. The company's obligations crystallize. The user's consent becomes a legal fiction they didn't author. One commenter caught something worth noting. This is an unpublished Ninth Circuit memorandum. It's not binding precedent. It applies to this case. That matters. The doctrine isn't settled here. It's being tested. Another commenter made the sharpest observation in the thread. If continued use implies acceptance of updated terms, and if both parties are subject to a mutual contract, what stops a user from emailing the company their own updated terms? The asymmetry is the whole game. The logic only works in one direction, and the court didn't grapple with why. What I find genuinely interesting is the engineering failure this exposes. Well-designed contracts, like well-designed AP is, version explicitly. They don't assume consent. They request it. They don't treat silence as a signature. The legal system is still catching up to what good systems architects figured out a long time ago. A handshake requires two parties moving, not one party moving and one party being told they move. Moving on. A font is 40,000 decisions. Spacing, kerning, weight, baseline, ascender height. Professional-type designers spend years on a single family. Fontcrafter collapses that into an afternoon with a felt-tip pen. Here's the devil's advocate position worth taking seriously. Handwriting fonts are almost always worse than professional typefaces. Uneven baselines, inconsistent stroke weight, quirks that charm once and irritate by the third paragraph. If you're setting body text for anything you want people to actually read, you're probably making a mistake with this. That's true. It's also entirely beside the point. Fontcrafter isn't competing with Helvetica. It's answering a different question. Can an ordinary person capture their own handwriting as a usable digital font? Without a design degree, without expensive software, without surrendering data to do it? The answer is yes, and the architecture is worth examining closely. Everything runs in the browser. No account, no server, no upload to a cloud pipeline that retains your strokes for model training or analysis downstream. You print the template at 100% scale. No fit to page, that matters. Fill in the character boxes with a felt-tip pen. Scan the sheet flat on a table and drag the file into the page. Phone camera works fine if the lighting is even and there's no curl. The processing happens locally. The font file comes out belonging entirely to whoever filled in the template. That's not a minor implementation detail. That's an architectural commitment about who the tool actually serves. The technical constraints are specific and earned. Ballpoints photograph too faint. Thick markers bleed past box edges. Felt tip is the calibrated middle. Strokes need breathing room from the borders. 3 rows per character. The extras can hold alternate letter forms or lowercase, your choice. The instructions read like someone who debugged this through real failure modes and wrote down exactly what broke. The commenter who flagged the privacy design understood what was genuinely interesting here. This capability exists in commercial tools. Accounts, subscriptions, data retention policies written in the passive voice. Fontcrafter made a different set of trade-offs. Local processing. No account. No terms that update quietly and assume your continued use as consent. Run this forward. Every tool that normalizes privacy by default raises the floor for everything else. The tools exist. The choice was made deliberately. That's the whole story. What if the agent running on your machine had the same respect for your privacy as the tool that just made its fonts? Story 3 is exactly that. The flag is right there in the install instructions. Dangerously skip permissions. That's the actual flag name Claude CLI ships with. And the creator of Agent Safehouse looked at that flag and built the one thing that makes it safe to actually use. That's the entire product in a sentence. The flag name is a confession. The CLI equivalent of a warning sticker on a power tool. Yes, we know, be careful. Safehouse is the engineering answer to. Careful how exactly. The mechanism is macOS seatbelt. Sandbox is kernel level in Darwin since 10.5. This is not a container, not a VM, not a network proxy watching traffic. The kernel itself intercepts every syscall. When the agent reaches for everf.ss's best CAD, the operating system says no before the process ever sees the data. That's not application layer security with edge cases and escape hatches. That is the lowest possible layer. The kernel decides. There is no lower court. The installs one shell script, no build step, no runtime, no dependency graph to audit, just bash and the macOS kernel you already have. Someone made a deliberate choice to ship this as something you can read before you run it. The entire trust surface is visible. That's a design philosophy, not a constraint. One of the comments lands something important without quite drawing the full conclusion. The threat model for local agents is actually 2 separate problems. The agent does something destructive by accident, and the agent exfiltrates data it shouldn't touch. These get conflated constantly. Sandbox handles both because kernel-level isolation doesn't distinguish motive. It just enforces the boundary, but the tooling conversation hasn't caught up to that clarity yet. The creator built this for local agents specifically, not cloud agents, not containerized workloads in a VPC, for agents running on your machine. With your full tool chain installed, your years of accumulated configuration, your keys and repos and personal files all living a few path traversals away from the worker. That context is what makes the design interesting. A local agent's threat surface is your entire home directory. The question nobody is quite asking yet, at what point does give the agent access and sandbox the rest become the default architecture instead of the clever workaround? One shell script, one clear boundary. The question hangs. Moving on. Pick up a laserdisc, hold it to the light. You're looking at a rainbow of reflections, the iridescent sheen of aluminum under lacquer. You're also, if you have a microscope, looking at the actual movie. That's what's happening here. A microscope, trained on a laserdisc surface, resolves the pits, the physical grooves encoding an FM-modulated analog signal. And at the right scale, you can see individual video frames. Literally see them. The image is in the disc, not abstracted away behind a decoder, not locked behind a handshake. The information and the content are the same thing. This is how analog storage works. The constraint they were working against in the 1970s was compute. There was no processor cheap enough to decode digital video in real time. So, they encoded the luminance and color signals directly as physical variation: high frequency, bright; low frequency, dark. The disk isn't storing numbers that represent video. The disk is video, impressed in plastic at microscopic scale. Here's where the bootstrapism angle gets sharp. The CED format. RCA's stylus-based rival. Worked like a rock phone chord player. Physical contact, mechanical reading, legible to anyone with the right instruments. Laserdisc used a laser, exotic in 1978, now a $2 component. Neither format required a server to authenticate your playback. Neither expired. Neither could be remotely revoked. You bought the disc, you had the movie. With a microscope, you could see the movie. That was the complete transaction. Compare that to what we've built since. HDCP, DRM. Content living on servers you don't control. Licenses that evaporate when companies fold. 4K streams that refuse to play unless the handshake validates correctly. The content is further from you now, not closer. More mediated, more permissioned, more dependent on third parties, staying solvent and cooperative. One commenter noted, you can see the end credits right there on the disk surface. The whole production. Cast crew copyright notice. Pressed into physical reality, readable by any instrument, with sufficient resolution. No account required. No subscription. No terms of service, updated unilaterally at 2 in the morning. The tools got cheaper, the access got more restricted. A microscope and a laserdisc gives you direct, unmediated access to the thing you own. That used to be the default. We chose to move away from it. That choice is still being made, every format generation, in favor of someone else holding the key. What happens when the tools themselves get so small you can put them in your pocket? Literally? Story 5. The strongest argument against celebrating a board this small runs like this. Capability follows size. Real embedded work demands pins, flash, peripherals, debugging surfaces. Shrinking to 8.9 by 9 millimeters. The footprint of the USB-C connector powering it doesn't create new possibilities, it just limits old ones. And a tiny 1616 with 2 GPIOs broken out is a demonstration, not a tool, a novelty, a thing you show people, not a thing you ship. That argument is coherent. It's also wrong for a specific reason. What constraint-driven design does is not reduce capability. It redefines the design space entirely. When your compute fits inside a connector, you're not cramming less function into less space. Run this forward 5 years. The cost of silicon continues its descent. Fabrication tolerances keep tightening. A community of designers, each working in Easy EDA or KiCad, each publishing their files, each building on what others made. That community produces thousands of form factors that no single company would fund. Not because the market is too small, but because no company can anticipate which constraints will matter for which application. The long tail of embedded hardware gets served not by product lines, but by individuals who needed something specific and built it themselves. This is what one person made, 3 boards panelized into one PCB order, purple solder mask, 2 layers, files on GitHub, the Angstrom I/O, a programmer with dual CH340EE, one for OPDI, one for serial. So you can debug and flash simultaneously without swapping cables. A CH32W003 experimentation board with a Charlie-plexed LED matrix, because learning a new chip means having something to look at. One commenter said they dreamed of an open board like the YubiKey Nano. That form factor exists commercially, closed, in exactly one configuration for exactly one purpose. What this builder made is the open version of that idea. A starting point anyone can take anywhere, in any direction, for any constraint they encounter. 16 kilobytes of flash, 2 addressable RGB LEDs, I2C power from a USB-C connector. The board barely extends beyond. The tools exist. The knowledge is available. The files are there. That's how this compounds. Story 6 is something different. The Watt Manson, the Sant K-Man Ject, but a chorus of them. What is the community actually building right now? The Homebrew Computer Club met monthly in a Menlo Park garage starting in 1975. The format was 2 parts. A mapping session where people showed what they'd built, and a random access session where anyone could say anything to anyone. Show up with something. Share what you know. By the end of the decade, those attendees had seeded Silicon Valley itself. Every March, Hacker News runs the same meeting digitally. What are you working on? And every time, the answers follow the same shape. Someone found something missing, so they built it. This month, a city builder taking the genre somewhere new. A journaling app written from scratch, because every existing one failed some personal test. The developer couldn't quite articulate, but knew instantly. A vector graphics scripting language that started as simple and became something else entirely. A search engine, EU-based, built as an alternative because the existing options didn't serve the region. An open-source analytics dashboard for teams running AI pipelines, who wanted to actually see what was happening. Now run the logic all the way out. Every commercial tool that adds friction, that locks your data, that removes a feature in a rebranding push, that monetizes the gap between what you need and what they're willing to provide. Creates a builder, not hypothetically. Actually, the person who couldn't find a journaling app they liked didn't file a feature request. They wrote iOS shortcuts and shipped their own. Take this to its logical extreme and you arrive somewhere the product managers never intended. The most aggressively extractive software companies are funding open source development. Not through charity, through frustration. Every time a subscription wall goes up, someone starts a repo. Every time a platform degrades its own product to serve advertisers, someone starts a fork. The incumbents are, inadvertently, the best accelerant for their own alternatives. The comedy isn't in the failure, it's in the accuracy. These aren't protest projects. The journaling app writer isn't angry. They just wanted to write. The search engine builders aren't crusaders. They wanted better results. The city builder developer wasn't dissatisfied with the genre so much as curious about where else it could go. That's the homebrew lesson that never made it into the mythology. The club wasn't primarily political. It was just people who found something missing and had the tools to fill it. The revolution, where there was one, arrived as a side effect. The meeting never ends. The garage just moved. And if the garage just moved, maybe queerly old idea moves with it. Pause Story 7. Literate programming and why agents might finally make it work. What does it mean for an idea to be right but arrive too early? Donald Knuth introduced literate programming in 1984. The premise is elegant. Code and prose interleaved. The document explaining the program, and the program implementing the document. The reader gets the what and the why in the same place. Beautiful. And for 40 years, largely impractical. The core killed it. Write the prose. Write the code. Change one. Update both. Humans are bad at this. We drift, we forget, we prioritize the running thing over the explaining thing. Org mode users managed it for personal configs. Data scientists made peace with Jupyter, but the mainstream didn't bite because the maintenance cost was real and the payoff diffuse. Here's what changes now. The agent is tireless. It doesn't drift. It doesn't resent re-explaining what a function does after you've tweaked it 4 times. Ask it to update the prose after a code change. Done. Ask it to write code matching a prose description. Also done. The fundamental extra labor collapses because the agent has no friction around translation. That's literally what it's built for. The author describes using Claude to write org mode runbooks for feature testing. The agent writes the steps in prose, writes the code blocks, tangles the result. You review. The prose is the model's reflection of intent. The code is its implementation. When something changes, you ask the agent to update both simultaneously. The problem of maintaining parallel narratives disappears. What's worth admiring is the craft of the reframe. Literary programming failed not because the idea was bad, but because it assumed a human partner willing to do symmetric work. Swap in a language model, which genuinely excels at translation and summarization, which never finds documentation tedious. And the assumption changes entirely. The idea was waiting for the right collaborator. One thing worth naming. Org mode is GNU. The methodology is fully open. Which agents you trust to implement it inside your systems is a real question. Architecture determines outcomes, and that's engineering due diligence, not ideology, but the pattern itself. Document as source of truth, prose as first-class artifact, code as expression of written intent. Belongs to everyone. Knuth wasn't wrong, he was just 40 years early. Moving on. Flip through the comment thread on this one, and a pattern emerges within the first few replies. Someone notes the lack of mainline Linux coverage. Someone else asks whether drivers have been upstreamed. A third asks about security patches in a year. The benchmarks are there. Geekbench scores, memory bandwidth, MPU's numbers. But the audience keeps asking the same question the article doesn't answer. Here's the first principles version of that question. An SBC isn't a computer. The AMS isn't a computer. It's a deployment contract. When you drop one into a project, a router, a sensor array, a kiosk, a learning environment. You're not just buying silicon. You're betting that the software stack will remain functional and secure for the duration of that project, which might be 2 years, might be 7. Beagleboard's Green Eco ships a Cortex A8 from 2009, specifically because that bet is already paid off. Decades of industrial support, known behavior, predictable failure modes. The performance is irrelevant. The contract is what you're buying. The rest of the field is less certain. 15 boards across 8 manufacturers. SoCSogs from Rockchip, Broadcom, Qualcomm, MediaTek, Allwinner, Star5, CIX, Texas Instruments. That's 8 different software support stories. 8 different relationships with the mainline kernel. 8 different answers to whether your board still receives patches in 2027. Qualcomm entering the SBC space through the Arduino UNO-Q is worth holding for a moment. Qualcomm acquired Arduino in 2023. The UNO-Q ships QRB221 silicon. Benchmark numbers are modest. 100 single-core, 570 multi-core, but Qualcomm's track REH cord on upstream kernel contributions has historically been better than most ARM SoC vendors. If that holds for the embedded tier, it's actually meaningful. The hardware story and the software story would finally point the same direction. RISC-V sits at the other end of the spectrum. $43 for 4 GB of RAM on Star 5's Vision 5 of RAM on Star 5's Vision 5 II Lite. Geekbench scores that are honest about where the architecture is right now. 4. The interesting question with RISC-V has never been whether it performs today. It's whether the software ecosystem matures before the window closes. 15 boards, 8 vendors. The benchmarks tell you what the hardware can do on day 1. The comments are asking what it can do on day 700. That's the actual test. What if the hardware that sticks around is the hardware anyone can build for? Story 9, FrameBook. There's a moment in any system build where you realize the hardest constraint isn't performance. It's the interface between what you've inherited and what you want to put inside it. I've hit this designing around fixed enclosures, routing signal cables through spaces built for components that no longer exist. The geometry doesn't negotiate. You adapt or you abandon. The people who do this well professionally are called preservation architects. They take a building designed in 1924. Load-bearing walls, narrow staircases, ceiling heights calculated for gaslight, and run modern plumbing, electrical and HVAC through it without destroying what made the original worth saving. The skill is knowing what's load-bearing in the soul of the structure and what's just substrate you can replace. This is what's happening at fb.edoo.gg. The FrameBook takes a 2006 black polycarbonate MacBook. Ayo body, the one with genuinely good proportions and genuinely bad performance, and fits it with a Framework Laptop 13 mainboard, Intel Core i7-12 Atto-P, 64 GB of DDR4. The original chassis becomes the reason this exists, rather than simply buying a new laptop. Framework's modular design philosophy turns out to be exactly the right donor architecture for this kind of transplant. The mainboard is meant to be removed. The dimensions are documented. The screws are standard. The technical path is detailed and honest about difficulty. Custom 3D printed standoffs fixed with Gorilla Glue. A USB-C hub occupying the space where old components lived. The Framework speaker kit slotted into obvious mounting points, but the centerpiece is the keyboard and trackpad. The original Apple hardware, salvaged and rewired. Someone had already documented how to tap into the case PCB and solder a USB cable to the existing circuitry, converting Apple's proprietary interface into something the Framework board could actually talk to. The builder had never soldered anything before. Watched the videos, felt confident, did the solder, plugged it in. It worked, then yanked the cable accidentally, tore the pads clean off the PCB, and did it again on a new top case. That's the sequence. That's how competence is actually built. Not credential, not tutorial completion. Consequence: the pads are small, and the penalty for inattention is immediate. And now this person has knowledge of physical computing that no amount of reading would have transferred. One commenter observes that the write-up buries the lead. You're several paragraphs in before understanding what's being built. Fair. But the energy in that prose is the point. I decided to just go for it. That sentence is load-bearing. That go for it energy. Pause. Storytime brings the same spirit to API tooling. Culture 10, one CLI, every API 96 to 99% fewer tokens. Every turn your AI agent takes, it reads the entire instruction manual for every tool it has access to. Every turn. Whether it's about to use the file system tool or not, the file system tool's full schema is there in context. Whether it needs the database connector or not, the schema arrives. You've connected 15 tools. Congratulations, you've added 15 instruction manuals to every message. Forever. Until you run out of context, window, or budget. MCP 2Kai's answer is just don't do that. The project ships as a CLI that connects to MCP servers and OpenAPI specs at runtime, generating subcommands dynamically from the live spec. No code generation. No static bindings. The schema is fetched once, cached locally, and the agent calls a command line tool instead of injecting full schemas into context on every turn. Token reduction, 96 to 99% on tool-related overhead, which means nearly everything you were spending on tool schemas was ceremony, not signal. This is the SOAP story. Around 1998, enterprise software standardized on SOAP. Simple Object Access Protocol, the name being generous. Every service interaction required a WSDL, a complete XML description of every operation, every data type, every possible parameter. Sent alongside each request, the schema became larger than the actual payload. Then, Roy Fielding published his REST dissertation in 2000, and the industry spent the following decade slowly admitting the obvious. You already had HTTP. You already had verbs and URLs. The description language wasn't adding information. It was adding weight. MCP is navigating the same arc. The protocol is genuinely useful, the part where full tool schemas are injected into context on every single agent turn is not a feature. It's an artifact of where the spec currently sits in its maturity curve. One commenter on the thread calls it a bug and expects chat clients to fix it eventually. MCT-TLI doesn't wait for eventually. The tune output format is worth slowing down for. Token-optimized object notation. A compact encoding designed for LLM consumption that cuts another 40 to 60% off large uniform arrays compared to JSON. The tool isn't just reducing schema overhead, it's asking a more interesting question. What should a response look like when the consumer is a language model rather than a human reading it in a browser? JSON is optimized for human legibility. Tune is optimized for the actual consumer. That's a real reframe. And it comes from the same place every useful tool comes from. Someone deciding the current setup was wasteful, building the fix, and putting it where people can reach it. This has been your daily tech feed for Hacker News for March 9, 2026. This podcast is entirely AI-generated. Scripts by Claude Opus 4.6. Voiced by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go build something that answers your own question. We'll see you back here tomorrow.